ng isang cooling tower. So, sa bawat unit operation, equipment used, unit process, gusto natin ng higher energy efficiency. So, sa cooling tower, gusto din natin yun. And para sa cooling tower, we have 4 considerations para magkaroon ng energy efficient cooling tower. Yan, ito yung 4 main considerations para sa pag-consider natin para magkaroon tayo ng energy efficient cooling tower. Number 1 is the selection of cooling tower. What are the parameters we want for our cooling tower? Second is the fields or the fill media. And number 3 is the pumps and water distribution. Number 4 is the selection of fans and motors. So, una natin tackle yung selection of a cooling tower. For selection of cooling tower, may desired capacity tayo. Yan, heat dissipation, kung anong gusto natin heat dissipation para sa ating cooling tower, kung anong gusto natin circulated airflow rate para sa ating cooling tower. Next. For the selection of cooling tower, yung range na i-consider natin ay yung range determined by the process, not by the system. Yung system, yung theoretical, yung process, yun nga, yung talagang tunay na mangyayari. Sa approach, gusto natin yung closer to the wet bulb temperature, ibig sabihin nun, di ba yung approach yung difference between the cold water temperature, yung out cold water temperature, yung lumalabas na water. Yung approach yung difference na pala ng wet bulb at ng cold water. So, ibig sabihin pag yung approach ay closer to the wet bulb temperature, we have a bigger size cooling tower. And ibig sabihin pa, syempre, pag mas malaki yung cooling tower, it is more expensive. So, heat load. The selection of cooling tower, we also need to consider the heat load. The heat load determined by the process. The required cooling is controlled by the desired operating temperature. Higher heat load means larger size, and larger size of cooling tower. Siyempre, pag laki ng cooling tower natin, mas mataas yung, mas malaki yung cost, mas malaki yung kailangan. So, higher cost of cooling tower. Sa selection of cooling tower, we also need to consider the wet bulb temperature. Water is cooled to higher temperature than wet bulb temperature. The design, the wet bulb temperature should not exceed 5% of the desired wet bulb temperature. This wet bulb temperature is specified as ambient, prepared by inlet. Yan, kailangan natin consider yun sa wet bulb temperature. At yung tower deal with increased wet bulb temperature. Flexible ba yung gusto natin cooling tower? Kung pag-increase natin yung wet bulb temperature, makakayanin ba ng cooling tower? So, yan, kailangan natin din yung consider sa selection of cooling tower and cold water to exchange heat. And kailangan din natin consider sa selection of cooling tower ang relationship of range, flow, and heat load. As range increases, the amount of circulated water also increases. So it means higher heat load. Kailangan natin ng mas heat load, higher heat load. So cost of range increase. Di ba yung range yung difference ng range is the difference of the hot water temperature and the cold water temperature. So, pag pinasa natin yung range, pwedeng either dito yung mangyari, and then water temperature increases, exceed water temperature increases. Pwedeng either or both. So, consequence of a range increase. So, syempre, if we have a higher range, that requires larger tower. Again, larger tower means more expensive cooling tower. relationship of approach and wet bulb temperature. Example, yung approach natin ay 4.45 degrees Celsius. And we have a higher wet bulb temperature, 26.67 degrees Celsius. Pag higher wet bulb temperature, more heat picked up. Then for 26.67 degrees Celsius, ang heat picked up niya ay 15.5 kilocal per kilogram air. More heat picked up, ibig sabihin, smaller tower needed. Lower wet bulb temperature, pag approach natin ay stays the same, 4.45 degrees Celsius. Lower wet bulb temperature naman gamitin natin, 21.11 degrees Celsius. Less heat is picked up. So, ayan, 12.1 kilocal per kilogram air. Compare natin dito, mas mababa. So, larger tower needed pag mas maliit yung wet bulb temperature natin. Second naman, yun, tapos yung selection of cooling tower. Second, consider natin is the field media. Hot water distributed over field media and cools down through evaporation. Yung field media, yung sa loob ng cooling tower, yung nagkukul, yung nagpapakul sa hot water through evaporation. So, field media also impacts electricity use. Efficiently designed field media, syempre mas efficient, more savings, reduces pumping cost. And field media also influences heat exchange. Surface area, i-consider natin yung sa field media, surface area, duration of contact, and turbulence. Ito yung comparison ng field media natin, usual field media. Meron tayo splash field, film field, low cloud field. So, ayan. Ito yung mga parameters na consider natin. Possible L/G ratio, effective heat exchange area, field height required, pumping head requirement, quantity of air required. So, kung papansinin natin na field has higher effective heat exchange area para sa dalawa, at pumping head requirement and quantity of air required is lower. So this means that mas advisable yung gamitin yung field. So field will cost savings and more efficient. Yung third na i-consider natin, we have already considered selection of cooling tower, field media. Sunod naman ay pumps and water distribution. In considering pumps and water distribution, we want to optimize cooling water treatments. So we increase in cycles of concentration, yung na-discuss ni kanina, cycles of concentration, or COC, by cooling water treatment, helps reduce makeup water. Yan, increased COC means reduced in makeup water. So, magkakaroon doon ng savings doon interest. Magkakaroon tayo doon ng electricity savings. Sa pumps and water distribution din natin, pwede rin tayo mag-install ng drip eliminators. Drip eliminators will reduce drip loss from 0.02% to only 0.003 or to 0.001%. So ayun, drip eliminators, eliminate, ayun nga, may eliminate yung drip, less drip, so more efficient pumps and water.